Alright, in this video we will be doing integration using the trigonometric substitution, or in short trig substitution. In order to use trig substitution, we need to remember trigonometric identities. If we don't remember the trigonometric identities, then we really cannot do the trig substitution. So what are the trig identities we need for this topic? The first one that everybody should remember is sine square theta plus cosine square theta equals to 1. Meaning, for any angle theta, the sine of the angle square plus the cosine of the angle square must be equal to 1. So this is the first one, which can be easily derived using any right triangle. So call this number 1. The second one, if I divide both sides by cosine square theta, this is what I will get. Sine square theta divided by cosine square theta plus cosine square theta divided by cosine square theta equals 1 over cosine square theta. And this is always true as long as cosine theta is not equal to 0. In most cases, this should be true. Alright, so what is sine divided by cosine? Well, sine divided by cosine is tangent. So therefore, sine square divided by cosine square is going to be tan square. So this is going to be tangent square theta. Cosine square theta divided by cosine square theta is just simply 1. And of course, this will be 1 over cosine is secant. So therefore, 1 over cosine square is secant square theta. So I'm going to consider this the second one. So the first one, sine square theta plus cosine square theta equals 1. The second one, tan square theta plus 1 is secant square theta. These identities are also very helpful when we will be doing integration that consists of sine and cosine or secant and tangent combinations, especially covered in Calc 2. So these are critically important. It's not to be confused, especially with this one. This one is usually remembered as this one is confused. A lot of people think it is secant square plus 1, that is tangent square. It's not. It is tangent square theta plus 1 that is equal to secant square theta. But the good thing is, I can also solve for tangent square theta from here, which will be secant square theta minus 1 equals tangent square theta. I can also solve for cosine square theta from here. Cosine square theta will be 1 minus sine square theta. Or sine square theta equals 1 minus cosine square theta. And those equations are the ones I need to identify which of the three trig substitution I'm going to need to integrate using the trig substitution. What do I mean by that? Well, for instance, let's say I want to integrate this. Let's say, I'm going to say example 1. Let's say I want to integrate this as simply 4 minus x squared dx. Well, think about it. If you do use substitution, it's not going to work by parts. It's not going to work. Probably it's going to be very complicated. So what do you need to do? Well, if you think about this one, think of a right triangle whose hypotenuse is 2, and one side is x. So the other side will be the square root of 4 minus x squared. Well, in that case, I'm going to think of this way. Create a triangle. Create a triangle. Let's say this one is a right angle. This is going to be 2. And let's say the angle is right here, theta. And let's say its opposite side is going to be x. Well, we know if this is going to be theta, this is x, this is 2, one of the sides is going to be 2 squared minus x squared using the Pythagorean theorem, which is going to be 4 minus x squared. And this leads me to think, okay, then I can actually change this into trig using theta. And which one am I going to use? Which of the three trig substitutions do I use? Well, I have to think that when I substitute, I need to get rid of this guy completely from the radical. I need to have a free, out of the radical, basically. So I have to do a little bit of the math here. So in the worst case scenario, I'm going to try 3 of them, and whichever works, I will use. But also to make things, easier, it's good to memorize. So let's consider x equals 2 times sine of theta. 2 times sine of theta. Well, how do I know that? Because if I solve for sine theta, that's going to be x over 2. And it makes sense to say sine theta equals x over 2 here. So if sine theta equals x over 2, so x equals 2 sine theta will be a good way to substitute. Remember, sine theta is opposite over hypotenuse. So the opposite of the angle theta is x, the hypotenuse is 2, so therefore x equals 2 sine theta. Maybe it's good to remember from here. Probably you can start from sine theta equals x over 2 from the triangle. But usually you would get this one first because you probably will memorize. Okay, so if that is the case, I'm going to just differentiate both sides. So that's going to be dx equals 2. Well, the derivative of sine theta is cos theta, cosine of theta. Then I would have d theta, of course. So dx equals 2 cos theta d theta. But since I have x squared here, if I square both sides, these guys will give me also x squared equals 4 sine squared theta. So x squared is 4 sine squared theta. Dx is 2 cos theta d theta. Then I'm ready to change this guy, everything in terms of theta. So that will be the integration of the square root of 4 is 4, of course. X squared is 4 sine squared theta. 4 sine squared theta. This dx, that's usually the one that is forgotten. Don't forget this one is in terms of theta is 2 cosine theta d theta. 2 times cosine theta d theta. If I factor out 4, that will give me 2 out. So this will be 2, so square root of 1 minus sine squared theta times 2 cos theta d theta. Okay? So that's, of course, integration. So 1 minus sine squared theta from right here, 1 minus sine squared theta will be cos squared theta, takes the square root, it will be cos theta. So therefore, this will actually be 4 times the integral of cos theta times cos theta is cos squared theta d theta. Okay? So my integral is changing completely everything in terms of theta, and that will be 2 times 2 is 4, so 4 cos squared theta d theta, which of course will require the power reduction. How do we integrate cosine squared theta d theta? I'm going to leave this one there to just use it later at the end. So I'm going to do power reduction. So 4 is 4, of course. Cosine squared theta is 1 plus cos of 2 theta over 2 d theta. Okay? So you can keep this in parentheses if you will. Then split them. So that's going to be 4 over 2 d theta plus 4 over 2 cosine of 2 theta d theta. So 4 over 2 is 2, so this is 2 theta. That is also 2. The antiderivative of cosine of 2 theta. Well, that's going to be done by substitution. If you do this one as u, your du will be 2d theta, of course. So that's going to be divided. So there will be sine 2 theta divided by 2. How do I know that? Because, well, I always do differentiate in order to check if what I say will give me, when I differentiate, will give me this one. And it will, because 4 over 2 is 2, that's the numerator, but the 2 is, you can see when I differentiate this, sine of 2 theta, its derivative is cosine of theta times 2, because of the chain rule, so that will cancel it to give me what I have. So this is good. So, of course, plus c because you have indefinite integral. So 2 theta, our final answer is 2 theta plus sine of 2 theta and then plus c. Yeah? So, well, I'm not done yet because theta is kind of an intruder. I mean, it's a new variable that was not the original variable. So I need to replace this theta in terms of x. Well, then how do I do that? I'm going to use my triangle. So theta could be considered as, if I see over there, arc sine of x over 2 is perfectly fine. So that will be 2 times arc sine of x over 2. Sine of 2 theta is 2 sine theta cos theta. 2 sine theta cos of theta. Well, of course, plus c. Sine theta again is arc sine x over 2. So there's going to be 2 arc sine of x over 2, which is the first one, plus 2 times, again, arc, no, hold on, sine theta is x over 2, so that's going to be x over 2. Cos theta is adjacent, which was square root of 4 minus x squared over 2, so that's adjacent over hypotenuse, then plus c. So you can reduce this one to just give you x root of 4 minus x squared over 2, and that will be my final answer in this case. So therefore, let me just write my final answer. Therefore, the integral of 4 minus x squared dx, as simple as it looks, was not. It's going to be 2 arc sine or sine inverse of x over 2 plus x square root of 4 minus x squared over 2 plus c. And that is the final answer in this case. Okay, so that is the final answer in this case. Right, if you have any question or any comment, put it on the comment section, and probably I will add another example, maybe to make it a little easier to understand.